As I've talked to you in the lesson before, we have some effects that we can make to make artificial stereo illusions. But why these illusions are possible is because of the physical naturality of the actual sound and how we perceive it. Now, first of all, I mentioned the Haas effect, and I showed you this when we were dealing with the delays. Now, let's do some of that again. Let's deal with the delay. I'm going to use a simple delay right here on the synthesizer. And now, as you can see it, and when we measure it, this is a completely mono signal. Of course, without this delay. See, completely mono. What I can do is, let's say, delay one of the channels, the left or the right, by a certain amount of time compared to the other, and it will sound much more stereo. Now let me play only the wet of both of these. So you can hear the difference. If you're listening to this on stereo speakers, or even better on your headphones, you can hear the immediate difference of how wide and surrounding this sawtooth sounds once we introduce this delay to one of the channels. And we can, of course, see that on the correlation meter. Now, that's one of the effects that physically exists in nature, that once a sound is on the left or the right of us, one of our ears is going to pick up on that sound sooner than the other. And that slight millisecond difference is really important for our brain, because our brain can decipher that difference, since the sound reaching both of the ears is identical. And the brain does not only listen to that time difference between them, it's also the filtering and the change that is introduced to the sound by the sound being filtered by our face, since our face is in the way of the other ear that's further away. So all of those factors is what our brain uses to decode the positioning of a sound. Now, this is how complex and beautiful our listening apparatus really is. It's all in the brain. It's all in the decoding of the information that reaches us. So by just delaying one of the channels, we can make this sound that is really mono, really sounds in the middle, like it's coming from right in front of you right now, to make it sound really wide and all around. Now, another physical effect that appears in nature is the Doppler effect. And I'm going to show you a Doppler effect just using an effector that actually uses that, and it's called the Doppler. It just emulates a passing by of the sound source. So imagine if you were moving towards the sound source, or the sound source was moving towards you or away from you, the pitch of the sound source would change. Now, the most apparent example of this is listening to a passing by car, which goes higher in pitch, higher, and then it passes you, it goes lower in pitch again. Let's try that out with this sound. I'm going to try that with this actual effect on, and you will hear what that produces. So that is the actual effect. We can go right to left, of course. We can move it the other way around. Now, why does this happen? Why is the pitch changing when the sound source is moving, or you are moving your position compared to the sound source? Well, so as you know, sound is transmitted in waves, and if you move towards the sound source, or the sound source is moving towards you, every next wave that is produced by the sound source is actually reaching you quicker. This is why the pitch, when the sound source is coming closer to you, or coming closer to it, is rising. Since every next wave reaches you sooner and sooner, it creates an illusion of the sound source having a higher pitch, and higher and higher and higher the closer it gets to you. It's actually not the closeness, but it's the movement that produces that illusion. If the sound source was standing still, you would hear it at a single pitch, and that would be it. But it's the movement that produces the illusion. Now, if the sound source moves away from you, every next sound wave of the air coming to you comes later and later, because it's moving away the source that's producing that air pressure, and you get the illusion of the pitch going down. Now, let's hear that again, what that sounds like. That really sounds like a car on a track. It's really recognizable, and anybody living long enough actually knows what that sounds like. And you can hear that from any moving object that produces a sound. So it's called the Doppler effect, and the one that we talked about earlier, where we have one of the channels delayed in time to produce the effect of stereo 2, it's called the Haas effect. Now, these are two important techniques for you to know, which can help you create an illusion of stereo when you need it, even when you have the sound source that is completely mono.